Here's another example. This side has a length of 3, this side has a length of 6, this is a right triangle. Try to figure out this angle and this side. Try to use the same notation and approach that we used on the previous problem. We use asterisks to indicate the information that we've been given. And also, even though I have not been given this angle, I'm going to put an asterisk here just to remind myself that this is the angle that I'm focusing on when I use the trig functions. And now we can label that this side is the hypotenuse. The horizontal side here is adjacent to the asterisked angle, and this vertical side is opposite to the angle that we're focusing on. Now this is, again, a problem where we've been given two sides. We have to find the angle and the hypotenuse, and you can do that in either order. You can find the hypotenuse first, or you can find the angle first. I think usually most people generally find the side first, so that's what I'm going to do in these videos. Well, the way to do this is not to use a trig function. The way to find the hypotenuse here is just to use the Pythagorean theorem. Remember, the Pythagorean theorem says hypotenuse squared equals leg squared plus leg squared. Now we'll plug in. What do I plug in for the hypotenuse? Well, I don't know the hypotenuse. What do I plug in for this leg? 6. And what do I plug in for this leg? 3. Don't forget that we're squaring the hypotenuse on the left-hand side. 6 squared is 36. 3 squared is 9. 36 plus 9 is 45. Oh, I'm getting really sloppy here. I keep forgetting that we're squaring the hypotenuse. All right, so we have the hypotenuse squared equals 45. Now our goal is to solve this equation for the hypotenuse. We have to get the hypotenuse term by itself. That means we have to get rid of the square. Well, we do the opposite. The opposite of squaring is taking the square root. So let's take the square root of both sides. If you take the square root of the left-hand side, we're just left with the hypotenuse. And if you take the square root of the right-hand side, we get the square root of 45. And of course, we're taking the positive square root. Now we can use our calculator to figure out the positive square root of 45. That's 6.7. So our hypotenuse is 6.7. That's probably the easy part. Maybe the hard part is to find this angle over here. Well, the first thing is that it's going to be a lot easier if we give this angle a name. So let's call this angle theta again. I'm going to call this angle theta. Now, which trig function should I use? Well, remember that we're going to try to use the information that we've been given. Well, we've been given information about the opposite side and the adjacent side. That's what these asterisks are reminding us of. We have this number 6 and this number 3. So we want a trig function that deals with the opposite and the adjacent sides. Well, TOA, that's the tangent. Tangent deals with opposite and adjacent. Tangent of theta is opposite over adjacent. If you wanted to, you could use the hypotenuse, now that we know the hypotenuse. We could solve the problem another way using the hypotenuse. However, that's not the way people usually do this type of problem. They usually do the problem using the information they were originally given, not the new information they figured out. So we'll do the problem the way it's conventionally done. Well, we can plug in that the opposite side had a length of 6, and the adjacent side had a length of 3. 6 divided by 3 is 2. Now, we still need to get the theta by itself. We need to get rid of this tangent term by doing the opposite. What's the opposite of tangent? Well, we know now we've learned that the opposite of tangent is inverse tangent, or arctangent. we have to take the inverse tangent of both sides. Well, when we take the inverse tangent of the left-hand side, that just leaves theta by itself. But by the golden rule of algebra, since I just took the inverse tangent of the left-hand side, I must take the inverse tangent of the right-hand side. So we know this is one good way to write the inverse tangent. And now we have to get our calculator and figure out the inverse tangent. By the way, again, you would read this, tangent of theta is 2. And this says theta is the angle whose tangent is 2. Theta is the angle whose tangent is 2. Theta is the inverse tangent of 2. That means that theta is the angle whose tangent is 2. Anyway, we can use our calculator here. Remember that you probably have to use the second key on your calculator. You have to hit second and then tangent to get the inverse tangent. And then you can hit 2. So on most calculators, this is how you would do this inverse tangent. You'd hit the second key, then you hit the tangent key, which gives you the inverse tangent, and then you hit the number 2. If your calculator works differently, you'll have to figure that out on your own. And then if you do the inverse tangent of 2, you will find that the inverse tangent of 2 is approximately 63 degrees. So we can say that this angle here is 63 degrees. Now, as usual, the way I'm solving these problems is not the only way to solve them. There's actually many different approaches you can use to solve these problems, but I'm using the approach that is most commonly used in physics, and that's the approach that I recommend that you use as well. Try to solve the problems the same way I'm doing, because that's the way that you're conventionally going to see your textbook and your instructor solving them, even though there are other ways that would also give you the right answer. For example, it is possible to find this angle without using the tangent. You could use the sine or the cosine once you know the hypotenuse, but that's not the way people usually solve this type of problem. So this is our next example of how to solve a problem where we're given two sides. We've seen that this is a lot different from when you're just giving a side and an angle. All right, please keep redoing this problem until it's boringly easy. Only then would it be a good idea to move on to the next example.